Okay, Roland, please go ahead.
Okay, so the second last presentation for today is on the introduction to polychlorinated biphenyls, dioxins and furans, and other unintentional POPs, and the related inventory development. So in part one of the presentation, I will shortly show the listed unintentional POPs in the Stockholm Convention, then some basic information on dioxins and UPOPs, including toxicology, 1 or 2 slides about formation of unintentional POPs, and then in part 2, I will introduce to the methodology to establish comparable dioxin inventories with the UNEP Dioxin Toolkit, and at the end, some conclusions. So in the first original 12 POPs, we had already 4 unintentional produced POPs listed. So this included polychlorinated dibenzodioxins, short PCDDs, the polychlorinated dibenzofurans, PCDFs, and also polychlorinated biphenyls, which Michael introduced to the industrial produced PCBs, but they can also be formed, for example, in incineration as unintentional POPs. The same with hexachlorobenzene. And then in the last 10 years, there were more unintentional POPs listed, pentachlorobenzene, polychlorinated naphthalines, and hexachlorobutadiene. So today we have now 7 different unintentional POPs groups listed. But what is all common for these unintentional POPs groups are that they are produced in the production of organochlorine chemicals, that they can be produced in processes where we have elemental chlorine present, and then also in thermal processes like incineration or metal industries where all forms of chlorine can be present. Article 5 of the Stockholm Convention says that each party shall reduce the total release and, if possible, minimize and eliminate the release of unintentional POPs. So here you see the structure of polychlorinated dibenzodioxins and furans. In total, we have 210 different molecules which are dioxins and furans, but only 17 of those are toxic. So the way how we calculate for the Stockholm Convention is only one number for the dioxin sources, and these are calculated with the toxic equivalency factors, so-called TEQs. So here you will see later in the presentation that we are talking about gram or kilogram of this toxic equivalency factor. And this reflects these 17 congeneers. So you will not have to deal with these different congeneers at all. The history of dioxins and furans is closely related to the chemical production of chlorinated aromatic chemicals, like here the chlorophenols. Maybe some chemicals you might know is pentachlorophenol, or short PCP, which has been listed as a POP in 2015. But there are also some pesticides like 2,4-D, which is one of the major pesticides used today, and 2,4,5-T. These were also included in the so-called Agent Orange in Vietnam. And in these productions, the dioxins were included in those products. And we have one famous old pesticide production in Hamburg. And this actually produced this lindane and HCH, which Richard mentioned before. And in this factory, we had about 330 to 850 kilogram of this TEQ today in the landfills in Germany, and one of the biggest landfill just in the middle of Hamburg. And this number you can compare with the total dioxin release for 1 year of all sources and all countries in the world, which is estimated to about 100 kilogram. So you see that in the past, the organochlorine industry produced far more dioxins and released it to the environment compared to the sources of today. This we can see with the only detailed historic dioxin inventory, and this comes from Japan. So you see here the dioxin release from Japan from 1958 until 2010. And here the concentration is in gram of the TEQs. And you see here Japan in the 1960s and the 1970s, every year in average had a release of about 30 kilogram of TEQ. And the sources were pentachlorophenol used in rice fields, the chloronitrophene used also in rice fields, and also partly the PCBs have dioxin toxicity. So also here, this total release from pesticides of 460 kilogram TEQ in history to the rice soil in Japan, you can compare with the 100 kilogram TEQ of total release of dioxins of today. So still from this application in the history in Japan, all the rice field soils in Japan are contaminated. And over the last 50 years, these soils have released the dioxins in particles into the rivers and into Tokyo Bay. And so when you measure, for example, in Tokyo Bay, a sediment, this is a sediment here, not from the Tokyo Bay, but in Tokyo Bay, it will be similar. This is here a sediment from Switzerland, and they have sliced this sediment and checked the different layers of the sediment and the dioxin concentration from 1850 to about 2000. And what you see in this sediment here for Switzerland, here for Germany, but the same in Tokyo Bay, you see that the dioxins in red, they increased here in the 1940s, 1950s, 1960s, very strong. And already in the beginning of the 1970s, the levels in the sediments are decreasing. And what you see here in blue, that's the PCB. And the PCB has the same contamination in the environment in our countries. This means, like Michael said, PCB started the production in 1930s, and then you see after the 1930s, 40s, 50s, the PCB levels in parallel to the dioxin levels increased in the environment. And already in the beginning of 1970s, where Michael said at that time the first legislation came and the PCB open application were prohibited, the levels of PCBs and the level of dioxins are strongly reduced by more than 90% in our environment. And the funny thing is for the dioxins that actually also the dioxin reduction measures in Europe started in the 1980s. So you see, actually the reduction measures started at a time where already the largest amount of dioxins had already been released into the environment from the history of organochlorine production. Yeah. So, but these releases now here from incinerators and so on are smaller compared to the past releases from the chemicals. When we look now we come to today. Yeah. So when we look to today into the dioxin inventories, we see that the largest contribution of dioxin global releases to the air is open burning, followed by waste incineration and the metallurgical industry. So here you see for the different regions in the world here, Africa, Asia, Pacific, KUWAIT region, industrial countries, the orange is the dioxins from open burning. Yeah, here Africa, about 70% of all dioxins in the inventories is estimated to come from open burning. Also other region here, KUWAIT, South America, more than 50% come from open burning. Yeah, and then you have the waste incineration. the metallurgical industry, and the waste incineration. Yeah, so this is the situation of today, and today dioxin releases of the inventories of the last, let's say, 15 years developed from the Stockholm Convention implementation. And I can promise you, most probably, when you look to Palestine, also open burning will be a major source for dioxin releases for Palestine. Coming to the life cycle of dioxins, yes, we have different emission sources, like the thermal sources, incineration, but like I said, a very big contributor were chlorine production, organochlorine production. From there, it comes into products like the pesticides, and then from there, it either goes to landfills, or like for the pesticides, is directly applied to the land, going to the aquatic, to the rivers. And by this, over the last about 100 years, we have contaminated our soil and our sediments with dioxins. And what happens today is that these dioxins emitted are accumulated in animals and in fishes. And here, by this, finally, we have an exposure by food ingestion then to humans. And unfortunately, dioxins are very persistent, are also very persistent in humans. So over time, over the decades, dioxins accumulate in humans, and then they can be transferred to the next generation by human milk. So I can promise you already this morning with your breakfast, with your lunch, maybe you have your lunch in parallel to the presentation, you got some dioxins, because today all of the food from animals are contaminated or at least impacted by some dioxins and by some PCBs. And the largest concentration you have in the fatty food, like cheese, milk, beef, fish. So what you see here, this is the exposure from food in the United States, and more than 90% normally of dioxin exposure comes from this kind of food. The exposure is a little bit different for different countries. Here you see the main exposure for Japan. In Japan, they eat much fish and seafood. So in Japan, more than 50% of all dioxin exposure come from seafood, but also a share comes from milk and meat. And at that time, when this exposure assessment have been done in the end of 1990s, Japan had a high capacity of waste incineration. So therefore, you see here some exposure also from vegetables impacted from waste incineration. The question is for you and for other Middle East countries, what are the dioxin and POP exposure from food in the Middle East? For Palestine, I don't think that there are really data, but there are data from Kuwait. So you might look here for Kuwait study for a first indication on the levels of dioxins in food in the Middle East. What I said is that dioxins accumulate in humans, and finally they are transferred to the child by human milk. And what you see here, this is the result of dioxin measurements in human milk of the WHO human milk study. And the green one, this is the dioxins in human milk here from different countries, including Egypt. And the yellow one, this is the concentration of dioxin like PCBs. And you see in the study in 2003, Egypt had the highest dioxin level in human milk from all countries which have participated. Yeah, and also a little bit of PCB contamination. The good news I want to show you here is that Egypt in 2019 made a new study of the human milk. And what you see that the levels in Egypt in human milk over these, let's say 15, 16, 17 years have decreased in average by more than 50%. Yeah. So this human milk at the same time is the effectiveness evaluator and the matrix which we are using to show progresses in Stockholm Convention implementation. But still, the human milk also in Egypt today is by more than an order of magnitude above tolerable daily intake for humans recommended. But still, when you do a risk evaluation, mother milk is still the best nutrition because there are so many advantages of mother milk. So therefore, the recommendation, despite we have some dioxins, we have some PCBs in human milk, is from WHO that babies should be breastfed best for 6 months and more. So what are the toxic effects of dioxins? There are acute effects like chloracne, and some animals and humans in accidents have died from dioxins, but these are really at high doses. What you see here is the former Ukraine president Yushchenko, and he was poisoned by dioxins. So this is a picture before dioxin poisoning, and this is a picture after dioxin poisoning, and here got a few milligrams of dioxins in his food, and so he developed this chloracne. But important for us is the daily exposure and the chronic effects of dioxins. So this includes tumor promotion, effects on the hormone system. Dioxins are strong endocrine disruptors, and very important is developmental toxicity to the development of the fetus, and then also later of humans. So coming to only one slide about dioxin formation. So we said we have thermal sources, and these thermal sources, they emit soot and polyaromatic hydrocarbons. So the soot, everybody knows, the black smoke coming out of the cars and the chimneys. So this is the chemical structure. And when you have in your processes, thermal processes, then metals and chlorides, then this soot is oxidized and is substituted by chlorine. And by this degradation, finally, the dioxins and furans are formed. And with the same mechanism, also PCBs can be formed here, polychlorinated naphthalines and all other unintentional POPs. So the mechanism here for the dioxins and other unintentional POP is the same. So therefore, internal processes like incineration and metal industry, dioxins and other unintentional POPs are formed together with a certain concentration, and this depends on the quality of incineration and, for example, the chlorine content. And therefore, when you look to the recommendation, for all thermal sources, dioxins and other unintentional POPs can be minimized and eliminated by the same measure. So when you reduce dioxins, at the same time, you also reduce all other unintentional POPs. So therefore, it's recommended by the UNEP Toolkit, which gives you guidance for the inventory of dioxins, that for practical reasons, normally our inventory will only focus on dioxins. And so here the dioxins, they are then indicative for the presence of all other unintentional POPs. Yeah, that it does not become too complicated and that countries calculate all other unintentional POPs. Yeah, so there are also some methodologies to assess and calculate other unintentional POPs. But I would say here for Palestine, this is a rather exercise for a university. And you as a policymaker, you can concentrate just on an inventory of dioxins with the UNEP Toolkit. So that's also here one of the first steps recommended by Article 5 of the Stockholm Convention. These are the measures to reduce and eliminate unintentional POPs. So here in part A, the Article 5 says, countries develop an action plan within 2 years of the date of entry into force. So now Palestine could or should develop an action plan, and this action plan should be designed to identify, characterize, and address the releases of chemicals. And the first thing that we can develop an action plan is we need to have a dioxin inventory, because only if you have an inventory and you know what are the major sources, then you can develop an appropriate action plan. So because of that, here the paragraph I of Article 5A says an evaluation of current and projected releases, including the development and maintenance of a source inventory. Yeah, and that would be then the first part of your activity in respect to dioxins and other unintentional POPs. And here in a few slides, I want to introduce you this UNEP toolkit, which is for free and accessible in the internet. And after my presentation, Shireen will give a few words also in Arabic that everybody can understand. So here, the UNEP toolkit is for the identification and quantification of releases of dioxins and furans and other unintentional POP. This is an emission factor methodology. So here, all major research of the last 40 years of dioxin research are compiled in this document for emission factors from different sources. So this means that in Palestine, you would not need to measure the dioxin emission from the different sources, but that you would use here this toolkit. And here the toolkit aimed to assist for parties like Palestine in establishing release inventories that are consistent in format and content, ensuring that it is possible to compare the results with other countries, identify the priorities, and mark also the progresses by then developing new inventory after 4 or 5 years. So that was all the link. So here, this is the content of the UNEP toolkit. So here in part 1, you have a general guidance, and this is a guidance about giving the background on dioxins. Also, this document gives you guidance on updating and revising the inventories. And by this, you directly afterwards, those are interested in dioxin inventories, you can go into the internet and read in the part 1 and get the background information. Then in part 2, there you have the default emission factors. So here you have for all the different sources, emission factors for waste incineration, for hospital waste incineration, we will come to it, and for open burning. And these default emission factors would be used here also for Palestine to assess the dioxin releases. There is a part 3 of the toolkit. This includes some example inventories. So for each major source, there is an example inventory from another country where you can have a look and read and learn from other countries how they compiled for the different sources their inventories. The calculation afterwards is that you look to your different sources. Like, for example, you might have hospital waste incineration, and then you would look for the source strengths. So for incineration, this would mean how many tons of waste is incinerated, or if you have a steel plant, how many tons of steel is produced per year. And then you would look to the emission factor in the toolkit, and then by multiplication of your activity rate, this means how many tons of waste you have incinerated maybe last year, and the emission factor from the toolkit, you can calculate the total amount of gram of dioxins of a certain source. And this you would do for the individual sources. So here the UNEP toolkit has established a 5-step approach. So first, the toolkit has a list of source groups, and the first step is to identify what source groups is present in Palestine. And in this source group, there are different source categories. You would look what kind of source categories are present in Palestine. these are the different source groups. So in total, the toolkit has 10 different source groups. So you would look for Palestine, what main source groups you have in Palestine. So waste incineration, maybe you have some hospital waste incinerators. Then you can check if you have metal production, power generation. We said, yes, in Gaza, you have a power plant. Then production of mineral production, if you have a cement plant or not. Transport sector, this means cars and vehicles. Open burning, uncontrolled burning of waste. Then different productions and processes from chemical industry, probably you do not have, but maybe you have some pesticides you import. And then disposal sites, like sewage and compost or the normal household waste. And for all these different source groups, the toolkit have emission factors for all source groups to air. And for some source groups, for example, waste incinerator, also there are emission factor for the residue. This means, yes, when you incinerate, finally you have some emission to air, but also you get some ashes, which are then dioxins in the residues. So coming to the first source group, that's waste incineration. And the toolkit here have within the source group different source categories, because there are not only one type of incinerators, but there are about 8 types of incinerators. But for sure in Palestine, you do not have all the 8 different types of waste incinerators. Yeah, but in Palestine, maybe you might have a medical waste incinerator, yeah, with a hospital. Yeah, then you might check if you have a municipal waste incinerator. Maybe not. Then a hospital hazardous waste incinerator, maybe not. Yeah, but you see here, the toolkit is very structured, and you can go through the different source groups and then through the different source categories. And only for those source categories which you have, you would look for the different data, how many tons are, for example, incinerated. Yeah, I show you a second group. This is here the ferrous and non-ferrous metal production. So also here you have about 10 source categories. In most countries, there is some iron and steel production and foundries. You can check. You might not have most of these sources, but I think one source which I suspect that you have in Palestine is this thermal wire reclamation. This is when people burn cables to recover the copper, because copper is very valuable. So therefore, in basically all developing countries, there is some small informal businesses which are gathering the cables, and then they are burning the cables. So I think also for Palestine, we will find some of this thermal wire reclamation. So these were the first two steps. Yeah. So first, looking through the different source groups. In the source groups, you look to the different source categories, and then you gather the data for the individual source categories. And then for all the individual sources, you decide of emission factors. And here you have information in the toolkit, which gives you guidance how to select emission factors for different facilities. And then the fourth step is then the quantification, this multiplication of the different sources with the emission factors. And by the compilation, then finally, you have a full established inventory. I give you just here one example here for hospital waste. In hospital waste, you have good hospital waste incinerators and bad hospital waste incinerators. And the toolkit gives you here a guidance for different type of hospital waste incinerators. Here for one category, low technology combustion and no air pollution control device. It gives you emission factors to air and to residues. Yeah, or controlled combustion and a small air pollution control device, then the emission factor is already 10 times less. Yeah, And if you have a high technology combustion and continuously controlled combustion, then the emission factor is very low. Yeah. But you see, by this, when you then see, okay, we have let's say 2 hospital waste incinerators, you would go to the hospital waste incinerators, you would assess the quality of the technology, and also you would get the amount of waste which is incinerated in a year, and then you can calculate here your dioxin release from these sources. Yeah, this I have just done here for hospital waste incineration for one country. So in this country, they said, okay, we have some bad hospital waste incinerators and some which are somewhat controlled. Then they have found that the total tonnage per year, 10,000 tons for both of these categories. And by multiplication, then you can calculate here the dioxin release here for this case study. It was 400 gram for the bad incinerator and 30 gram for the better incinerators. Also, they have the same tons of hospital waste burned. So this is, let's say, the basic for the calculation of your dioxin emissions from the different sources. And the last category is then here for contaminated sites. What I showed you in the beginning for Switzerland, Japan, or for Germany, dioxins are unfortunately really very persistent in soils. So in Germany, we have facilities which have which were the start of chemical industry in the world. So they were operated from 1820 to 1880. And when we look today to the soils there, to the deposits, the dioxins concentrations there are still high. This means after 100 and 200 years, the dioxins which have contaminated soils are still there. Therefore, the last section is the source group 10. These are contaminated sites and hotspots. And I think that's also interesting for Palestine. So here, Article 6 of the Stockholm Convention encourage parties to develop strategies to identify sites contaminated with POPs, including unintentional POPs like dioxins. So here, the source group in the UNEP Toolkit includes an indicative list of activities that might have resulted in the contamination of soils and sediments. And so here you can just go to the toolkit. It's nicely guided in category 10 and look what kind of potential contaminated sites you might have in Palestine. So I have here a suggested reading. Dioxins I do since more than 25 years. In 2018, for the German government, I had done a study for 3 years about contamination of the environment in Germany in respect to food safety. So here, this has open access. And by reading this publication is about 30 pages, you get to know most of the things you need to know about dioxins. So 3 steps for contaminated site inventory development for dioxins. First, identify historic activities that could have caused contamination. So here you can go to the toolkit. This gives you about 10 sources. One of these sources are, for example, PCB transformer fires, because PCBs contain some dioxins, and when you have a fire, they produce more dioxins. Then to do an assessment for the individual sites, what kind of magnitude the contamination might have. And then also to do a ranking of the different sites in respect to exposure. This means, is this site somewhere where children are playing, yeah, or somewhere where you have a grazing of cattle or chicken, yeah. And then the third step would be a monitoring. Yes, like the professor raised the topic, yes, in Palestine, no, you do not have at the moment any capacity to analyze dioxins or PCBs or other POPs, but we have the regional center in Kuwait. And the last 3 years or 2 years, I have supported also Iraq and Bahrain. And what we have done there, we have made a link to the Kuwait center. And if you have relevant soil samples where you are interested in POP pollution, there might be the possibility that they can be sent to Kuwait for further analysis. But this negotiation you need to do directly with Kuwait Center. But we have people here from the Kuwait Center, which will give on the third day a presentation and introduce their capacity. And I think that could be one step for you to get more information on POP contamination in your country. For dioxins and emission sources, we should not concentrate only on dioxin emission. When you have a power plant or waste incinerator, you have also emission of heavy metals, of particulate matters, polyaromatic hydrocarbons. So therefore, my recommendation is when you look to emissions, combine it. For example, you might also have a ratified Minamata Convention on mercury, and normally those dioxin sources at the same time have also emission of mercury and are in the mercury toolkit. So you might combine these kind of inventory activities. Second last slide. Yes, I introduced you the life cycle of dioxins and the emission to the environment and contamination of the environment. What you see here is a solution and the part of the action plan, what you need. And this is very much waste management from the different sources, waste management from industries, and best available technology, best environmental practice implementation, which for sure is difficult for Palestine, but at least best environmental practice. This is how you operate an incinerator. You can teach and learn operators. You can teach and learn how to manage the ashes and so on. Yeah, so let's say this slide is already a part of solution to reduce your dioxin and unintentional POP emission in Palestine. Conclusion: Palestine can develop its baseline dioxin inventory with the UNEP Toolkit. Assessment what source groups and source categories are present in Palestine, gathering the activity rates of the individual source categories, classify individual source categories according to the situation of individual plants, like is this incinerator good or very good or bad or very bad, and then to choose the select the emission factor. Also assess source group number 10 on contaminated sites. So the dioxin toolkit also includes some other estimates of unintentional POPs, but like I said, this is rather something for a university. Maybe I can talk with the professor afterwards if he has a student, because I had several countries where really the university and the students developed the dioxin inventory, which I think is a very nice bachelor work or master work to support. And when you do that, please make sure that the detailed data of the inventory is kept in an appropriate database. Like also Michael said, for PCB, it's so important that you have a database which is maintained because you will need an update of the inventory and you will need to compare emissions, the old emissions with emissions maybe in 5 years, in 7 years, to see if you could reduce dioxins or if some sources have increased. Yeah, thank you for your attention.
Thank you so much.